Hello everyone, this is Sharia. So in this video, we are cover our first header file called algorithm, and in this video we are also cover our theoretical concept. And in this video we are use a code editor called VS Code, also a notepad, okay, note online board if it's need, okay. So first you can see here our file called name algorithm.cpp, and in this file we are cover everything start to finish, okay, start to finish, okay. Now you can see the course title called algorithm and our course name mastering C++ programming comprehensive programming guide all header file, okay. This is our Udemy course title, okay, and the author called Shahriar Hossain Shah, okay, this me, and credit goes to CPPCon, CPP standard library and ChatGPT, okay. And GitHub, what is the GitHub repo? GitHub repo, if you find the source code of this article or this code, you can find the search the Google call Algo Science Academy, then you can find the first of the column in our code, okay. Here you can see our license called LGPL, means laser graphics general license, means you can use it any purpose, or you can use it as a commercial way, like anything, okay. This is our update date and last update date, okay. And this is also a MIT license, also our uh, university license called International Islamic University Chittagong license. Also this license are provide a copyright license 2025 GPL license, okay. This is the license, okay, you can read it if you wish, okay. So let's get a start our first topic, okay. Okay, so what is the algorithm? If we means what is the algorithm, so the algorithm, what is the algorithm header file, okay. The algorithm header file in C++ is a part of standard template library, okay. What is this? It is called STL, okay, standard template library, okay, and provide a rich collection of function to perform common operation, okay. We also perform a common operation, which is that container like std vector, std list, std dequeue and other, okay. It focus and non-modifying and modifying sequence operations, sorting, searching and more, okay. So here you can see the two concept called non-modifying and modifying. In this particular video in code section we also cover in the modifying section, modifying sequence operation, we also cover modifying sequence operation, we also cover non-modifying operation sequence, okay. In the lecture, the very first I can talk that we most of the code we also cover in modifying sequence operation, but in the last of the code we can cover in non-modifying section, okay. So here you can see the our algorithm features. What are the algorithm features with our column? In this column I write and I make it so beautiful, okay. So algorithm features, so okay, first we can see our modular and reusable code, okay. This is a algorithm features. What are the algorithm features? Modular and reusable code, okay. You can use as a modular or reusable code. Non-modifying sequence operation, modifying sequence operation, sorting and partitioning, okay, partitioning, then searching and merging, and also heap operations and set operation and random algorithm and utility function, okay. So first column, okay, first column, first row is that modify modular and reusable code. What is this? Okay, contain a generic algorithm but can operate a variety of container type, okay. That it is a like a container, we also cover the container, and this is a generic algorithm type that can operate in variety of container types, okay. Use iter to provide flexibility to in work as a different container type, okay. Okay, and this is called a non-modifying sequence operation. That function do not after the input. That in the short time we can say that in non-modifying section we never change our value or never determine when we determine it or searching, sorting or find, sorry, not searching, sorting, okay. Searching, sorting, or find operation or see out operation, we never change our value, we just change our particular task, we will not change our value in the non-modifying section, okay. So which is the non-modifying section are, it is called find, count, all of, okay, etc. We can cover it, okay. Now next, the modifying sequence operation, okay. Function that modify the container or range, okay, like that, copy, remove, replace, okay. Then sorting and partitioning, okay, including effect sorting algorithm like sorting, stable sorting, partitioning algorithm like std partition, okay. Searching and merging, provide a function like binary search, merge, lower bound, we also covered that, okay. Heap operation function like, in this video we are not cover in heap, in the later video we also cover, if I wish we also cover heap section, okay. Function like make heap, push heap, pop heap, also that, okay. Set operation, okay. In this lecture we also cover set operation function like std union, std difference, and other short range of mathematical set, okay. Randomize algorithm, in the function like std shuffle and std sample for randomized range, okay. Next is the utility function, helper function like std mean, minimum or maximum, or clamp and std lexilogical, okay, compare. Then here is the general category of algorithm, this is the our general, this is our features, and this is our general category of algorithm, okay. So you can see what is our general algorithm category, okay. Okay, so you can see non-modifying sequence operation, operation do not change the original range of the value, okay. That operation that do not change the original range of the element, okay. What is that? Std find, std count, and std mismatch, we also cover in these three in the code, okay, code section. Modifying sequence operation, operation that modify the original range of the element, operation that modify the original range of the element, okay. What is that? Std copy, remove, and replace, okay. Then sorting and partitioning, okay. Operation that sort a partition of the element in the range, okay. This is that. And binary search operation that search the element of the sorting range, okay. Binary search, lower bound and upper bound, okay? And heap operation, set operation, random and numeric operation is that std accumulate, inner product, and shuffle, simple, std set uniform and set difference, okay. And make heap, push heap, pop heap, okay. Okay, now our algorithm function, what are, there are 1 2 3 4 5 6 or 6 type or more type of algorithm function, okay. In major 6 type, okay, algorithm function. Here you can see our non-modifying sequence operation, all of the non-modifying operation or sequential operation function type, and modifying sequential operation type, here the all, okay, all the modifying sequential function type, okay. This is our short and partition type, this is our all modifying and partition type function, and binary search function, and also heap function, and also set union function. This is our all function type, and random algorithm function. If you need any particular tutorial or code, you can just copy the code and also search the Google, that can give you a particular code, okay, particle code. But in this lecture I cover only, if I see that, only 18, and okay, I also cover 23 modifying code, and also some of the non-modifying code, okay. So here you can see modify, also sorting and binary also. So if you can see, here are bunch of all like that 100 or like that function cover here. this video, if I cover all of the code or all of the function code, this uh, tutorial also going to big in the number, so I just put a important function to show you the main thing what is the algorithm function does. Okay, so let's get start our function example. Okay, this is our first example called std max element. Okay, where is the our max element? Okay, if we search, okay, max element, okay, here I can see where the max element. Okay, max element, if we search that, max element. Okay, okay, max element, I just see the max element. Okay, here you can see the utility function also a std max. Okay, so first, okay, 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 here you can see our first max element and mean uh, std mean element. Okay, our first tutorial is that or our first example is that is std max element and std mean element, means maximum element or minimum element. Okay, okay, here is the answer and also a comment for. Okay, so in this example we need first three header file call algorithm, vector and IOSTM. To do so, here our vector symbol to vector operation, we also include a vector header file in standard cout and cin operation. We also include IOSTM, and most of them are algorithm like max element. So we to that time we also need a algorithm header file. Okay, so here is our code and we also see our operation. Okay, so what is our operation? First we create a vector, call std vector, will angle bracket and call this type is integer. Also here you can see the number is our vector type. Also we include a equal sign. If you not equal any equal sign, that's it, no problem with that. If you use, you can use. And here our vector index 0 element, index 1 element, index 2 element, index 3 element, index 4 element with 5 position 4 element. Okay, and why we use here in auto is like that, it automatically catch the all of the type. Okay, here all of the type, if it need automatically catch it, then we use our auto keyword. Okay, then auto keyword is called max. Okay, then max we declare like std max element number that begin, number to begin. Okay, begin to number in. Okay, number begin to number in operation, and that we output maximum element. Okay, and here you can see iterator symbol. Okay, iterator symbol max it to iterator, because we need a value, we not need any reference. If we not use the asterisk sign here and here, that cause a error. Okay, this cause a error, that find, if we not use this asterisk sign, that find our reference. But we also, but here we need our value. Okay, if we need our value, that we can here assign our iterate symbol. Okay, this is called a iterate symbol. Okay, and in our first line, okay, this is our max value. In the particular vector we also find what is our max value, and this is our logic code, and this is our mean value logic code. Okay, start to finish, begin start to finish. Okay, in minimum element. And if we, okay, if we run our code, okay, like that, Here you can see if we copy our code, sorry, okay, if we copy our code, okay, if we then if we go to the algorithm, then we find maximum element is 30 and minimum element is 40. Okay, 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 this is our first example. Okay, then our second example goes to the short operation with custom comparator called lambda function. Okay, we also here understand our lambda function. Okay, okay, here you can see we input a three header file called algorithm vector and istm. Okay, this is our shorting algorithm, also a custom comparator or lambda. Okay, lambda function. Okay, you can see this is a same as we cover in our previous code, like that is, and here you can see we not use any equal sign. If you wish you can use equal sign, or if you wish you can not use any equal sign. Okay, that's fine. Okay, here you can see we just use the steady short. Okay, steady a standard short, and in this code we use auto max it. Okay, what is the difference? Okay, what is the difference is that? Okay, we also use this type of operation called direct direct algorithm operation. We if we store our algorithm, we also create our store operation, then we has to call it like max it. Okay, but in this particular section we not use any call it, we just create a loop to output our code. Okay, create a loop. If we just one thing remember, that if we use anything called loop here, if we need our code to use a loop, that time we not use anything like a auto to store our algorithm. But if we not use any loop, okay, like that, if we not use any loop, that time we use anything like that to store our algorithm. Okay, then we call it in the out section. Okay, so here you can see our std begin, std in this in section we also use a call custom lambda comparator. Okay, custom lambda comparator, this is our lambda symbol. Okay, and this is our lambda parameter. Okay, and this is a lambda return type, that it has to be a number a or number b or integer a integer b, and this will check if a is greater than b. Is a is greater than b, then the operation like that. So what are those? Okay, int and number, and this is a call C11 or C++ as standard 11 for operation. Okay, standard operation to modern operation, like modern for operation. Okay, this is a modern for operation to simplify our code. Okay, then we just print our code, then we just out of that and return of that. Okay, if we run that, okay, here is our sorting with descending order, like 30, 20, 15, 10 and 5. Okay, descending order. Okay, why is that? If we here you can see, you can set up is greater than, okay. If we here setup is less than, then here you can see our code will be the first option is 5, then 10, then 15, then 20, then 30, okay. This is a main difference, okay. Okay. Okay, now our third example called std unique to remove consecutive duplicate, okay. We remove, if we remove any duplicate section our code, then we can perform it, okay. Okay, here you can see our three major header file called algorithm, vector and iostream, and our standard vector, okay, number, okay. Here you can see the number 1 is double, 2 is double, and 3 and 4 is double, and 5. If we need any operation, like we just remove our duplicate number, then we use our this operation, okay. So in this operation you can see the main factor or main character is to this line, okay. And in this particular line, this line and this line are as the same as it is, you can see it, okay. So why is that? If we comment this line, you can see what happened, okay. If we comment this line and just run it, okay, here you can see uh, it remove like 1 2 3 4 etc and 5 etc, like 5, nice, but it cannot remove our in section like number in like 4 5 4 4 5. It just work only for the 4 of the index or 5 of the position. The later position or it also like its work only for beginning, and the number in section it not work. So to do this we also call it like that erase, like means erase it. What is this? In it, this it in number in number in, not beginning, in number int, okay. When this is occur, then we find our actual value, okay, like that, okay. 1 2 3 4 5, okay. This is our code, okay. Okay, the next section is to partition, okay. Partition, okay. So here you can see our three major header file, okay. Three major header file, okay. And we here call our main function test, okay. Then we here use to steady standard vector type, okay, number. This is our number, okay. So here is the our operation to that we partition, like that we partition our in even, sorry, we partition our in even or odd. Like very first of the beginning we use our even number, and the last of the section we use our odd number, okay. In this, to do so, we first to put our partition to partition point in auto type keyword, okay, or return type. Then we here our logic like number begin, number in, also in lambda function to see that it modulate to equal 0, that it modulate or it division to the 0 2 with the answer is 0, then it call a even number first, okay. Then this is even, then first number beginning we can partition it our even, then the last section or very last section in int section we also will find the odd number, okay. Then we print out and our loop will be start that see 11 standard modern loop. Okay, and we never use here iterate. Okay, so if we run it, okay, if we run it, you can see it here. You can see 246 and 135. Okay, 246, 246 and 139. Okay, and this is our another function called transform function. Okay, transform function. Okay, our three header file called algorithm, vector, and IOST. Then we create our two two vector call. One is number also here, and another is integer type square number. Also here we can see the number dot size. Why we need a size? Because we in this size we can declare it, we can square it. To do so, we in the parameter section we use call number dot size. Okay, then we our declaration section here std transform begin int and square dot begin, that square is beginning. Then our lambda function. Okay, then we return our square possibilities. Okay, then this is our code. Okay, this is our code. Okay, and you can see if we not anything like size call function, that will remain a error. Okay, compile time error. Okay, then if we run this, okay, if we run this, okay, you can see our 1 4 9 16 25. Okay, okay, our next code we perform to merge. Okay, we merge a two vector in one. Okay, if we do that. Okay, so to do so, first we declare our number one vector and we declare our number two vector. We also declare our number three called merge. Also here the merge in parameter we declare, you can see vector dot size plus vector two dot size, that we can merge it or we can addition it. Okay, then we call our then we set our function call as std merge vector 1 dot beginning, vector 2 dot beginning, vector 1 int, vector 2 beginning, vector 2 int, and merge dot beginning. If we see that in this section we not use any lambda function. Why that? You can call me why that? Because in this section we already operation our code like that. Here you can see our this operation. Okay, this operation we also perform in this section. Okay, okay, so here we can see we call vector 1 vector 2. Okay, vector 1 vector 1 and vector 2 vector 2, also a merge, that will be beginning, that in the output we have beginning. Okay, so if we run that, okay, if we run that, okay, if we run that, here you can see our 1 2 3 4 5 6 7 8. Okay, this is our number. Okay, this is our another modifying sequence vector. Okay, algorithm. Okay, okay, and this is another called standard binary search. Okay, if we perform any binary search. Okay, okay, here you can see, to remember that in the binary search section we also the output, we every time the output will be true or false, that we operation in boolean operation. Okay, in by only for binary search case. Okay, also you can see some of the boolean case in non-modifying sequence search section. Okay, So you can see binary section. Okay, then we can perform that. In the binary section, bool found that binary search begin to end also in 5. Okay, also in 5. So you can see if that binary search has a 5, this 5 is not this 5, we just assume that is 5, this 5 is not this 5. I can say this 5 is not this 5, we just assume that this is a 5 in this range. We just thought that this algorithm has a 5 or not. Okay, this has a 5, we just use any ternary operator, like if we found this found, we just use any ternary operator, that found if yes or no, for found if yes or no. So you can see we just any general thought that here is a 5, this will be true, but in this section, in this vector, there we cannot see any 4, so this will be the our no section. Okay, so if we run that we just justify this is true or false, then we can see here is the 4 is found 0 and 5 is yes. Okay, okay, binary search and remove people. Okay, okay, the remove it. Okay, so like that, here is our vector call 1 2 3 4 5 6. Okay, like something like that. If we remove anything, like if we remove any odd number or if we remove any even number, that we can perform this remove if operation like that. Here you can see if we remove any even number. Okay, even number, then this is our remove if, then the number is begin and number is end. Also this is our lambda function called return. Okay, this is our lambda function, and also we compare it, the end is modulate to equal to 0, then it remove in. Then also if we remove anything, we also call the number like that erase. Okay, erase it. Where is the it? This is the it and the number it and our for operation. Okay, if we run that, okay, if we run that, here you can see 1 3 5. Okay, okay, this is a rotate, most important. It is our rotate function. Okay, rotate function. Here you can see we can generally input declare our header file section, also we declare our main function and also our vector. Then the start is that the rotate. Okay, the rotate begin. Okay, then with by the begin with number plus 2 and the number int. Okay, number int with the first number, this is our first number, and second, third, fourth, and also this is our int section. Okay, and if we rotate element left, if we rotate our element left, like this is our right, this is our left in plus 2, in plus 2, in this is not a 2, this is also called every time plus 2. Okay, then what will be our output? First we see our output, then we understand it briefly. Okay, okay, you can see 3 4 5 3 4 5 and 1 2. So let's get to understand our this particular section, okay, let's understand our particular section. Okay, here you can see our drop it. Okay, okay, this is our drop it. we just use it. Okay, this is our drop it, and this we just cover any rotate simply just. Okay, here you can see our index 0 1 2 3 4. Okay, index. Okay, if we just draw it. Okay, our index 0, our index 1, our index 2, our index 3. 0 1 2 3 4. Okay, this 4. Here you can say this is a 1, this is a 2, this is a 3, and this is a 4, and this is a 5. So if we just left, like if we just left in 2 plus in left. Okay, left. Okay, left 2 plus in element. Okay, or index. So here with the output. Okay, first we create another box, another row. 1 2 3 0 1 2 3 4. Okay, so in the 2 plus section in left, first our first case will be 0 1 2. Okay, this 2 will be our first, this 4 will be our second, this 5 will be our third. Okay, so here is the answer is 3 4 5, and the rest of this will be the 1 is to our 4 position, sorry, 2, 1 will be our will be our 4 position, and 2 1 2 3. Okay, okay, this is our 2 position, like that. 1 will be our 1 2. Okay, and 2 will be the 1 2. Okay, this is our 2, and this is our final output is 1 and 2. Okay, this is our final output. Okay. If we just simplify that, 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 like that, we just consider as a vector. We just consider a vector called 1 2 3 4. Okay, and this, if we consider this is our answer. Okay, if we consider this is our answer. Okay, 1 2 3 4 5, or 4 index. Okay, if we go leftly in 2 plus, like this is our right side and this is our left side, like left side. Okay, this is our left side to the plus 2 index element. Okay, so how we can do that? Plus 2 index element, like this will be the this section, this will be the this section, this will be the this section. Okay, and first 2, this will be the this section, and this will be the this section. Okay, this is fine. Okay, okay, this is our rotate. Okay, and element. Okay, now we here use ant element. Okay, ant element. Okay, so here you can see our first 3 header file is that same as the same, and our main function also our vector. We create a vector called 3 1 4 1 5 9 2. So in this section we just sort place of the third element. We just sort place of the third smallest element. in position. Okay, so this is particularly sort to the place of the third smallest element. So in the third or smallest element is 1, 2 and 3. Sorry, only 3. Okay, only 3. This is our third smallest element. Okay, we just place in the position. You can see our code is like same in our this code, rotate code. Okay, also our just for function. Okay, so if you guessed what is our code here. Okay, this is our code here is 1 and 1, then 2, then 3, then 4, then 5, then 9. Okay, uh, this is not like that. We just 1, 2, 3. This 4 element we place it for int like that, particularly partially short in the place to the third smallest element. So start smallest element 1, 2 and 4. Okay, the output of the answer is will be the 1, 1, 2, 3, 5, 9 and 4. Okay, so if we just do that. Okay, sorry, I just miss up. I think I have a got mistake that our first we just here our answer will be the 1, 1, 2, 3, 4, 5 and 9. Okay, 1, 1, 2, 3, 4, 5. So what will be the perform that we just call our third smallest element. Okay, element. What is our third smallest element? Is that our third smallest element is the 3. Okay, in this vector our third smallest element is the 3. So we place it, and if we here if we use any shorting or any erase like that. Okay, like if we here use any array. Okay, then we'll what happened. Oh, my VS code going to wrong. Why is that VS code? Okay, this is our set union operation. Okay, set union operation like that. Okay. And we just here just here 4. Okay, this is our right. Okay, right one. Okay. This is called set union. Why? What is the union? That is like a union call. That's like a our march. If we see that this is like another march. Okay, but it has a different. Okay, like that. This is like a march operation. We already perform like that similar. Okay, then we create a set union to begin start 1 start in start begin and start 2 in then result begin. Okay, like this thing like a march. Okay, then we call our result. Okay, what is our result? This is our result. we call our result, then we resize it, we union it. Okay, we resize it, we union it. What is the union or intersection? That what is the union? That the answer also the union is that we also need one, like that 3 is the common. Okay, 3 is the common, 1 and then 3, 5 is the common, then 5, then 8, then 7, then 8, then 9. Okay, if we see that 1 3 5 7 8 9, this is the operation. So what will be the it minus 1 result dot begin? What is that? That means, okay, that it minus 1 result begin, that it will be the start, then the result, this plus result will be the minus of the begin, like that, that 1 minus our result, the result will be the our with which I outcome. Okay, let's stop, we just see how it occur. Okay, this is our main condition of our union section. Okay, this is our main condition of the union section, how we can perform it. Okay, so if we just cover it, okay, then we just quit, then this is our union section. Okay, this is our resize function. Okay, this is our resize function, that it gradually merge, and what is the minus symbol, that the similar of the number will be the, sorry, the similar of the number will be the reduce or erase, like that, to our minus operation here with the resize. Okay, 1 3, then it resize the 3 and 5, and then we resize the 5 and 7, then 8 and then 9. Okay, so our next operation is to find it. Okay, okay, find it. Now here you can see our first header file. Okay, our 3 header file and our vector call, then we just find it. We just what we find, what is we find, the find the first odd number. Okay, we just find our first odd number. You can see our first odd number is only for 1. Okay, our first odd number is 1, then we just give a logic that modulus not 2. Okay, not 2, like, and 0, then we find our odd number. Okay, we just see our first order number. Okay, if here not any odd number, then we print no odd number. Okay, but you can see our odd number is 1 3 5, so it has a odd number. Okay, so if we run it and see it, this is our odd number 1. Okay, this is our first odd number. Okay, then our reverse, if we reverse our code. Okay, we reverse algorithm. Okay, just you can see, just if we call a reverse, just if we call a reverse function, okay, in the algorithm, that will be the reverse. Okay, as the same. Okay, and we also here our for loop, standard modern for loop. Okay, so if we run that, what will be the outcome, like 5 4 3 2 1. Okay, if we run that, okay, if we run that, then the answer will be there here. Okay, okay, now we will go to our accumulate. Okay, we accumulate function. Okay, so accumulate means just concretization, concretiated okay, like that 1 plus 2 plus 3 plus 4 plus 5. The sum of the result will be the like that 15. So this is our accumulate function and this will be our perform. Okay, just in this section you can see that uh, we use a 0. Why will be the 0? In the sum operation we need a initial value. So in the initial value we need, then we just here need a 0. Okay, that's it. And you can see in the sum section we not use any iterator because here we not any perform any iterator function. Okay, we not use any iteration function. Okay, if we here are just put any stack, that will be the error. Okay, okay, what will be the error in that? You can see this is called a pointer operation integer value. Okay, this is not a iterator. Okay, then we perform another function called equal range. Okay, equal range. Okay, so here you can see our first our vector call 1 2 then 3 3 3 3 3 4 5. So equal range means in this range if we go our drop, okay, drop it, okay, reconnect. Okay, so what will be the equal range means? Okay, so first understand what is the range means. Like that this and this 1 1 to 5, this is called this is called a range. Okay, this is like a 1 to 5. Okay, this is called a range. Okay, this is called a range 1 to 5. And this range, like we have a range called 1 2 3 3 3 4 and 5. Okay, this is our range. And if we particularly search that our equal range, what will be our equal range? Like 3 is a 3 type. Okay, if we find our algorithm to solve it, what are the equal range? So in this particular section, if we found any equal range and we determine it like 3 to 3, okay, then we use this function called equal range. The output will be the 3 3 and 3 and the code will be the this. Okay, in this range we just use any variable or identifier called range. Okay, we just call any identifier or equal in a range. So in this range, okay, here we perform our for operation for uh, just modern base. Okay, as we can see in auto it. Okay, this is our auto it to the range to the first, range to the first to the range to the first, and it not range, not it not range second, it not range second, then plus plus, like that, and then this operation will be the iterate and the sum. If we run that, and we also understand what they play in the code, okay, like that. Okay, this is our, so we just see how it come. Okay, first, what is the, we just understand this operation. Okay, we just understand this operation. Okay, where is that? Okay, first we just here 1 2 3 3 3 4 5. Okay, first this is our range. Okay, this is our range. Okay, this is our range. Okay, then we just assign okay, we just assign it to check our same range. So first it goes here. Okay, it check our here. First it check here, like range dot first, like range dot, okay, range dot fast. Okay, range dot fast. First it check here, in it check 1. So you can see the one has a range 1, and then range it's check range 2. Okay, so you can see in these two ranges 1 and 2, this is not a similar range. Okay, this is not a similar functionalities or similar number. Okay, then it go to the, this will go to the here, and this go to the here. Okay, then it check this is a same range, then it input, then it take 3 and 3, then this will go to the this. Okay, then again it check these two 3. Okay, 3 and 3 will be the, sorry, okay, 3 and 3 will be the same, first this and this. Okay, then then it goes to the, then it goes to the 4, then it goes to the 4, and this goes to the 5, then it check these are not same. Okay, 3 and 4 this is are not same, 4 and 5 these are not same, then it come to the union section, and then finally it found 3 and these 2 3, then these 3. Okay, 3 10 3. Okay, so this is our last output, and this will be the increase, okay, this also the increase. Okay, first increase. Okay, then we see standard in place march. Okay, this is another type march. Okay, okay, so here you can see we just perform a march of two sort in a place. Okay, two sort in a place. Okay, also in 3 position. Okay, so in this algorithm we have just something called mistake, because this algorithm output are not the same as we need. So this is your home task that you can solve it and give me the right answer. Okay, you can see the example 16 your home task to in place March. Okay, also in place March 2nd. Okay, you can see this is your same task that in this here will be the something called wrong, or also here you can see same thing as the same thing. Okay, here will be the answer is 1 2 3 4 5. This is really your task. Okay, okay, min max element, then we cover our next permutation. Okay, min max element. Okay, just as fast we first cover in min element or max element in the first section, we just cover it. Okay, here you can see our result, and then we just put our number begin and in, just begin and in, then we search at what is the minimum, what is the minimum, that's result, iterate. Okay, this is a iterate first, what is the first, like 1, and what is the max, we just cover it. Okay, then we just example in 19 our next permutation. Okay, then this is our important permutation to our next permutation. Okay, this is our next permutation. Here is that algorithm and vector and IO stream. This is the algorithm and vector and IO stream. Okay, this is our standard vector 1 2 and 3, and this will be our next permutation called our for operation, then we out it, then our while operation, and these things we our permuted begin to it, and this is return, and this will be our answer 1 2 3, and this is the answer is. So if we just see that this is a very simple operation, our permutation operation, and this is our code. Okay, okay, better. Now our final section to, okay, now final section. Okay, adjacent difference. Okay, this is our adjacent difference section. Okay, this is our adjacent difference section, like that. Okay, we just call it the what is the difference our section, like 20 minus 10, like 10 in the difference section, 30 minus 20 is the 10 difference section, 40 minus 30 is the 10 difference section, and 50 minus 40 is the 10 difference section, and the 1 2 and 3 and 4 section we will be the find 10 10 10 10 in the 4 time of the 10, also in 5 time of the 10, because 10 is our initial value in the 5 time of the our 10. Okay, so in the this is our code, and if we just run it and see it, here is the our answer. Okay, if we need just that. Okay, okay, this is the include section. Okay, this is our include section, this is our include section. Okay, if we run it, okay, like that, here you can see this is our set 1 and set 2. If we include our section like that in include function, like include that, and just see that is the result is yes or no, like that. In this result, like 2 3 5 is the include our section set 1 2 3. If yes, then no, then no. Okay, if we run that, okay, and this is the yes. Okay, okay, our set interaction and set difference we also cover, okay, and our last modifying section is the set interaction section. Okay, just like a union or intersection, like that. If we just see over here, okay, just in mathematical term, like that. 1 2 3 4 and 5. Okay, and 5. Okay, this is our called intersection symbol. Okay, if you know that. Okay, then we put 3 4 5 6 and 7. Okay, this is another. Okay, in the intersection section we also find our two vector. What will be the number of the common, that we can see 3 4 5. 3 4 5 will be our common section. So in the answer will be the our 3 4 5. Okay, just like that. And if we see our code, here is the code, and we also see that in the union section and the intersection section we also find our iterate, or sorry, it will be our this and minus our begin. Okay, like that, minus. Okay, and we also here you can see our vector result is standard minimum. Okay, minimum. Okay, minimum that we set in the standard minimum, then we set 1 to the side and set to the standard minimum. Okay, we just call our minimum, then we just set it. Okay, if we save it, sorry, if we save it and if we run it, okay, this is our number. Okay, so we just cover our modifying section, and this is our last and final non-modifying section. Okay, so I just shortly cover our modifying section. You also know what's there. Okay, here you can see our first is all of this is our code, and this is our lambda function, and this is our code, and this is also spine the yes or no. Okay, if we run that and if we see that our answer is yes. Why? Our it's begin and int, also that begin and int, and it run that it has a even number. Okay, it has a even number. Okay, this is has a even number, that yes. Okay, then yes. Okay, then our any of. Okay, like that. What is any of that? 1 3 5 and 9, any of this particular vector has a even, then it will be run, and this will be the yes. Okay, okay, then our next is none of. Okay, none of. Okay, like 1 3 5, then none of the vector is not even, then it is yes, and answer will be the yes. Okay, then here is our for each. Okay, for each, like that, 1 2 3 4. So in this for each we just count our lambda function, that we just only print, we just lambda function we only print 1 2 3 4, that we only, if we see that we only just print our code like 1 2 3 4. Okay, like that. Okay, then we cover a find operation, our non-modifying section, that we just find. What is we find? The 3. Here is 3 and it's fine. Okay, not fine, then will be the answer is not fine. Okay, if we run that, we also see here is a 3, we also see here is a 3. If we run that, and we also see that what is the position of the 3 into, like that, 0 1 2, and there is the position of the 3. Okay, like that. Okay, okay, this is our find if, and this is our count. Okay, okay, like a count, that what is our count, and like that we count into how many times, like 1 2 3, then our answer will be the 3 time. Okay, okay, then our another is count if, like that, that it count is, it is, okay, first we 8 like that. 1 2 3 4 5, that count how many number of the event, there how many number 1 2, it is 1 2, then it will, the answer is the 2 event. Okay, if we run that and if we just see that these are 2. Okay, then our final section, final section of this. Okay, final section of this. Okay, then we mismatch like 1 2 3 4 5 and 1 2 0 4 5, then we just find our mismatch of this section. Okay, then if we first run our code, okay, then we just see our mismatch position is 2. How many mismatch we our position, that like that 1 2 1 2, this is same, 4 5 4 5, this is same, then 3 and 1 is our 0 1 2, this 2 position, only for 2 position is our mismatch, and this is our code. If we has a 3 and there is a 3, then we also find, if we just see that 3, then we also find there is no mismatch. Okay, if we just run it and see it, there no mismatch. Okay, okay, thank you friend, thank you everyone to watch this video till then, and best of luck, have a good day, thank you.